Hi everyone, and welcome to this new session of Global Angular Meetup, presented by Digital Media and Angular Mountain View Meetup. Before we start, I have a few announcements. We have some events coming soon for all of you that follow our events. Prepare yourself because we have Global Angular Meetup in Espanol for everyone that speaks Spanish. It is partnered with Angular Montevideo, and it's going to be July 15th at 3 p.m. PDT. So if you're interested in catching up with those. We're also having Global View Meetup on July 16th. And we're having a monthly mentoring session, Warming in Tech. This is a really good session. We've heard everyone loves it, so feel free to join that. We also have a GraphQL plus Flutter fireside chat in partnership with Hasura on July 28th. So if you want to know more about our events, you can follow us on this.media. And we have all information about our podcast, our blog posts, online events, and much more. My name is Daniel Marin. I'm a software engineer here at This.Labs, and I'm going to be your host today. And I'm also going to be helping you guys in the JavaScript Marathon, which we're starting very soon. We have a full stack React plus GraphQL in 60 minutes. We have fully zoneless high performance in Post Ivy, featuring Michael Latke. We have Intro to native script featuring Nathan Walker, end-to-end testing with Cypress featuring Cecilia Martinez, and serverless OAuth featuring Jesse Tomchak. For more information, you can go to javascriptmarathon.com, and we have all the information about this new month's marathon. For today, we bring you a special speaker. We have Doug Parker. He's a software engineer in the Angular team, Google. And he's going to be talking to us about what's new in the Angular CLI version 10. So I leave it up to you, my friend, so you can take up the stage.
All right. Hello, everybody. Thanks so much for having me. I really appreciate being able to come here and share some of the cool new stuff we've been doing. So my name's Doug, as he said. I work on the Angular team, specifically on tooling. I joined kind of last November-ish. So still a kind of relatively new team member. I've been mostly working on some of the new Ivy stuff, as well as a lot of Google internal stuff. So unfortunately, a lot of the work I have isn't quite in the public eye, but I've been involved with a lot of the V10 discussions. And so I wanted to share some of the cool stuff we have and hopefully convince some of you to upgrade and take advantage of some of these great new features. So to start with, some of the stuff we're going to be talking about is we have some new CommonJS warnings that you're probably going to run into first thing. So I want to explain a bit of the background behind those and how you can address them. I'll talk into a new strict flag that we've added to ng new, as well as go into some stuff with those first two pieces are going to take most of it. But also be talking a bit about TypeScript 3.9, some of the way we've changed tsconfig, as well as some new browser support changes and some deprecations as a result of this. So probably the first thing you're going to notice when you update to V10, you're going to update to V10, you're going to run ng build, and then you're going to immediately run into some warnings from this. You're going to see, oh, this file depends on some library, and then it's going to say CommonJS or AMD dependencies can cause optimization bailouts. So what exactly is this complaining about? And why do we care? Why are we bothering with this? It does provide some info, but I really want to dive into this to understand better what the problem is and how we can really fix this in our applications. So ultimately, this relates to is tree shaking, which if you're unfamiliar with the term, this is sometimes called dead code elimination. But essentially what this is where the compiler or bundler tries to identify all code in a build which it can certainly identify is definitely not used within this compilation, and be able to strip it out so that we don't have to send it to the client side and to the end user just for it to never be called. So if you're importing, 100 functions from a library and you only use one of them, you would expect that that one function should be persisted and actually shipped to users. And the other 99 should just be tossed out and shouldn't really come up. So to give a concrete example of this, let's say you have a very simple file that has 2 functions, one that's kind of uncool and not terribly interesting, another one that is really cool and does awesome stuff, and all the cool kids are using it. So I don't know about you, but I want to be a cool kid, so I'm going to call that function. Import it into another file. I import both of these, but I only actually call the cool one. The uncool one is kind of boring. We don't really want to use that. So you'd think that when we ship this program to our end users, you'd think that uncool shouldn't even be included in that because it's never called, it's never used anywhere. So the bundler, when it bundles these sorts of things, is able to identify this. It looks over here and it says, okay, we've imported uncool, but we haven't actually used it in any meaningful way. So it recognizes that it's able to delete this import and just get rid of it. And then now it looks through the rest of the program. It's able to say, okay, well, foo is only ever imported here and uncool isn't even imported. So we don't actually need uncool at all, and we can just strip out the whole function. So by doing this, the bundler is able to specifically identify that, this whole function isn't needed. We can just strip it out and not bother with it. That makes the bundle size a lot smaller for what end users download. Now, when it comes to CommonJS, things get a little bit trickier. So you can consider the very same example made with CommonJS. And if you've maybe heard the term CommonJS but don't fully understand what that relates to, CommonJS is essentially the kind of node syntax of using require to import things and then module.exports to export things. Obviously, if you're doing node code, then that's relatively common. Some older JavaScript libraries that maybe predated ECMAScript modules and the native import-export syntax tend to still be written with this. So if we consider the exact same example using module.exports, the bundler is able to make the same kind of inference on uncool. And it's able to say, well, this import isn't really used, so we can delete that. We can save a few bytes there. But then it wants to say, can we delete this actual definition, which is going to contain most of the code that we're really interested in. Can we delete this definition? And the thing is that it actually is referenced down here. So before we can delete the definition, we have to delete this reference down here. And so the next question is, can we delete uncool down here? And that's actually a much harder question to answer than you might immediately think. So for example, if we focus a little bit more specifically on this, and we see that we have a function foo and it exports, it just gets exported. In order to tree shake, the bundler needs to know, is module.exports.foo actually used anywhere? And in some cases, this is easy to answer. Okay, if we just do console.log test, this isn't using foo. If we do console.log module.exports.foo, in that case, it is used. You can get a little bit stranger as you start to do, string lookups, but this is kind of these 2 points are kind of the same thing. You'd expect the bundler can probably figure that out. But we can get even weirder with this. We can do module.exports and then do a string lookup and then use state-of-the-art ES 2020 string reversal technology, which apparently this is still the best way I can find to reverse a string. And in this case, we're actually converting oof into foo and looking it up. And so this uses foo, but it's definitely not intuitive. I wouldn't blame you for not realizing that. It takes a bit more mental effort to really figure out. And then you can go into this monstrosity. If you don't understand this, don't worry. I don't understand it either, and I wrote the thing. Looking at this, you ask the question, does this use module.exports.foo? And I don't see foo in here. I don't see exports either. I do see module, but it says it's not a module, and it's going into eval, so we know that we can trust this particular piece of code. And so really, if this is confusing and convoluted, that's kind of the point. Really, the takeaway here is that answering the question of whether or not module.exports.foo is actually used is a really hard question to answer. And it's very difficult for the compiler or bundler to figure it out. Even I can't figure it out as a human, so I don't know how I could really expect the tool to do it. And if you're curious, this does actually use module.exports.foo. If you run this line, it will print out the function, just in case you didn't believe me. So why do I bring this up? Well, because that question is so hard to answer, it makes it very difficult to tree shake those kinds of functions. And so the original warning where we complained that, CommonJS is causing bundle size de-optimizations, what we're really saying is that we want to tree shake this module, but it's really difficult for us to do that because of the way that CommonJS syntax works. In the warning, we actually say it's CommonJS or AMD. AMD mostly works pretty much the same way, so it runs into kind of the same issue. Now in Angular v10, we're going to start warning you about this on build and actually say that, we want to be able to tree shake this more effectively. The best solution to this is to actually switch to using ESM syntax, basically the native import-export syntax in JavaScript and TypeScript. That will tree shake much better. It's much more statically analyzable, which is why tooling can handle it so much more effectively. And it's an actual part of the JavaScript standard. It's the way the ecosystem is moving, so we want people to start moving their code in that path. But not only does this apply to your own code, it also applies to libraries that you use. And typically libraries is where you're going to run into it. So you really want to keep this in mind and try to, if you are using a library that's on CommonJS, you want to try to switch to another version that does use ES modules, or file a bug, ask the library maintainer to support it. Or if it's open source, you can always just contribute that fix yourself and give back to the open source ecosystem. I definitely encourage you to do that. Now, in the worst possible scenario, if this doesn't exist, first step you do, if you have a dependency that doesn't use ESM, file an issue about it. Actually ask them to support it. That is step one. Don't forget that. But step two, in the angular.json bundle, you can basically add an allow list of the particular CommonJS dependencies that you want to ignore with this warning. Definitely, leave it to do of like, we need to fix this later. We need to actually get proper tree shaking from these modules, but this can at least be a short-term workaround as you start to deal with these sorts of issues. So that's everything for CommonJS. I'm going to stop talking about that for now. The biggest feature that we have here is ng-new, or specifically the strict flag for ng-new. If you've not used ng-new itself, it's kind of the ideal tool to scaffold a brand new Angular application. And the strict flag, with this new strict flag that we've added, we've made the generated project a little bit more restrictive and a little bit more adherent to best practices that we've seen in the ecosystem. So to start with, one of the changes that this includes is it updates some new TypeScript flags. I won't go through all of them in depth because that would take a very long time. But the biggest one, in my opinion, is just the strict true for TypeScript. That gives you some of the more important features or more significant features like no implicit any and strict null checks, which in my opinion should just be enabled by default for all TypeScript projects. So I would definitely encourage you to use those. Even if you're not using the ng-new strict flag, you should definitely be using this one in your tsconfig. We've also added a couple new flags for Angular itself. These basically convert what used to be runtime errors into compile time errors. And so we can surface these errors a bit more quickly and kind of put it in front of you in the best possible way, give you useful error messages to be able to fix these problems. Kind of relates to using templates in a bit looser way. We want to be able to make sure you're getting the most out of Angular and TypeScript, which is why we enable these flags. We've also made a small change to TSLint. We've enabled the no any rule, which will basically make it a lint warning to use the any type. And the reasoning for that is just because there's a lot of developers tend to abuse any a little bit more than they probably should, and aren't able to get as much utility out of TypeScript as they really should be. And so by making this a lint error, we want to encourage people to use more specific types. If you really don't know a specific type, I'd recommend you use the unknown type, which is a bit more restrictive and a bit easier to avoid kind of shooting yourself in the foot at runtime and doing something you shouldn't be doing with it. There are some cases where you do really need any, and in those situations, TSLint has the ability to kind of disable things on a more specific case-by-case basis. I would recommend you do that in that way. In my experience, any is usually not necessary, and I typically will just default to unknown, and then I'll only ever upgrade it to an any if I find that I absolutely need it. And that tends to happen pretty rarely, so I would definitely recommend unknown as an improvement. We've also made bundle budgets a little bit simpler, or a little bit stricter, I should say. If you're not using that particular feature, essentially this is where when you make a new project, you get a budgets configuration. And if your bundle size for particular components happens to exceed a certain amount, we're going to warn you or fail your builds. So previously, when you just ran ng-new, by default, you would get either a warning when you exceeded 2 megabytes or an error when you exceed 5 megabytes for your initial bundle size. This is great and helpful, but typically users are going to start feeling this pain before they actually hit 2 megabytes. So we wanted to make this a little bit more actionable to developers. So for strict mode, we tighten these a little bit, and it'll warn you at 500 kilobytes and error at 1 megabyte. This is really just to make sort of surface these kinds of issues to the developers more quickly so that they recognize the impact that their changes have on the bundle size of their application. The last major change here, which is really unintuitive and probably the most kind of unexpected change from the strict flag, is that you'll actually find that you have 2 package.json files in your project. This is the one that you already had, but then you've already got, but then additionally you have one under the source app directory. And if you look at this file, it's actually pretty small. It's basically just this. I've cut out a couple comments here, but we have the name of it, it's private, and then sideEffects false. So what exactly is this flag? You probably haven't seen this before. What is the purpose of this? And it really comes back to, well, you guys seem to enjoy the discussion about tree shaking earlier. So let's talk a little bit more about tree shaking, where this comes into play. So if you're not familiar with sideEffects as a technical term, sideEffects is essentially just any externally observable change that comes from executing a particular piece of code. And that sounds kind of high level and very buzzwordy. So to give some concrete examples, if you add 2 numbers together and store it into a sum, that's considered pure. It doesn't have any side effects, mainly because it doesn't mutate any state. It doesn't delete any state. It doesn't change anything else in the system. It introduces some new state and kind of gives it the name sum, but unless you explicitly give somebody the name sum, they can't tell you ever ran this piece of code. So that's sort of a pure statement. By contrast, if you increment a counter, this does have a side effect. Anybody who has a reference to count can see that it has incremented and can see that it has changed. So this is a side effect that has happened in the system and that other code can identify. Now, why do we really care about side effects? I mean, there are a lot of advantages to pure code, and I won't get into all of them. If you really want to learn more, I recommend that you talk to your friendly neighborhood functional programmer who will tell you why pure code is amazing and why you should always write pure code. But for the purposes of this presentation, mainly it comes down to the fact that pure code is very easy to tree shake. Meanwhile, side effecting code is very difficult to tree shake. And a lot of this comes down to the fact that it's very hard for the compiler or bundler to be absolutely sure that a particular piece of side effecting code is safe to remove. You can think of it like because the first statement is completely contained in the sum variable. If you don't use sum, then it's very easy to identify that this line of code can be removed. And a linter will tell you that, hey, you're not using sum. You can just delete this line of code. But for count plus equals 1, it's a lot harder to be sure about that. It's a lot harder for tooling or for a developer to really be sure that, yeah, we can just remove this count plus equals 1 line. And you have to have a lot more contextual knowledge about your application. And so when the tree shakers, core purpose in life is to remove code that isn't useful, it makes it very difficult when that code is side effecting, and it's hard for the bundler to really be sure that it's safe to remove. And in particular, this comes up with top-level side effects. So top level in a file, what I mean by that is basically that it's not in like an exported function or a class. It's just executed at the root scope. And so what that means is that when you simply import the file, it's immediately running this code. And if the code that gets immediately run in this top level has side effects, that has some weird implications on tree shaking. It makes it a lot harder to tree shake those modules. So a lot of all these kind of weird buzzwords and a lot of things coming together in really awkward fashions. So I want to give a more specific example of this. So consider that you have a simple app that imports from a file, and then we log this symbol foo. So it's about as simple as applications can get because it's basically just printing. So let's look at this exports file. Exports is just a re-export of a couple other modules. This is sometimes called a barrel file. It's a pretty common pattern in larger libraries that they don't want you to import from export/foo and then another import from export/cache. They'd rather that they just re-export everything for you in a nice, convenient fashion. So it's a very useful feature of JavaScript and one that a lot of libraries take advantage of. So let's look a little bit more, at this foo, because this is just re-exporting foo itself. So, the foo file just has a foo string. And at this point, we pretty much see everything that this is doing, right? Do we even need to look at cache at this point? We can know what this is going to print. It's just going to print foo. But, what could cache possibly be doing that would ruin this for us? And it turns out a lot. Consider a relatively straightforward implementation of cache. In this scenario, we just have a list of numbers, so nothing too fancy there. We export two functions. One will add a number to the cache. Another one will return it in a mutable fashion, which it really shouldn't do, but that's beside the point. But I was kind of lazy with this, and I was thinking, like, I don't want to clear the cache all the time. It sounds annoying. I just don't want to bother with it. So I set up a timer, and I said, okay, every 1 second, just clear the cache. Again, using ES 2020 state-of-the-art array emptying syntax. And this, this is reasonable code. I think you might see this checked in somewhere. But, none of this is used in this particular application. We're not actually using anything from cache. You'd expect that this whole file should get tree shaken. And when the tree shaker looks at this, it sees that add item and get items aren't actually used, so we can delete those pretty easily. But then it comes to the question of, can we delete the cache? And that's a much harder question to answer because it's used within this set interval. What the set interval is doing is it's creating a timer, but then as it's clearing it out every time, we as humans can look at this and say that, well, the cache is always empty. You can't put anything in the cache, so why are we clearing it every second? But the bundler isn't smart enough to know that. It sees that, oh, well, the cache is used here. It's written here, so, I need to keep this code. It seems important. And a lot of this comes from the fact that set interval is a side effect, is creating a timer. And this happens, not only is it creating a timer, it's doing it at the root level here. And so this happens simply from the import through this cache import. And because of that, even though we're not using this, this still gets included in the build and still exists at runtime. So what can we do to fix this? Well, Webpack, which is one of the build tools that the Angular CLI uses, Webpack has a solution to this, which is called the sideEffects flag. And what you do is you put this sideEffects false in your package.json, and it tells Webpack that this package does not have any side effects at the root level that would affect module load. And so that allows Webpack to be much more aggressive about trimming out modules that don't need to be included in a build. So consider that if we do the exact same build, but with this sideEffects equals false flag, what changes in here? So we have the same import, just importing foo and printing it. The same exports, of just re-exporting these two files. And foo is exporting the same symbol. Now, what's interesting here is that Webpack knows that, okay, we need this foo function from our imports, and we've got it in this foo.ts file. So why do we need to look at anything else? And the only reason the Webpack does look at anything else is because there may be side effects that need to be included in the build. However, since we've now told it through this sideEffects false flag that there are no side effects, I promise you there are no other side effects that I care about, then it doesn't even really look at this cache file. I'm kind of oversimplifying things a little bit, but it doesn't even bother evaluating it or looking at any of its dependencies. And that means that you don't include the code that was in cache, and you also don't include any transitive dependencies that might be there. If your cache used Lodash to compare keys or something, that also doesn't need to be included. So because of this sideEffects equals false flag, Webpack's able to be much more aggressive about its tree shaking and make your bundles much smaller. There are a few caveats with this particular change. For starters, you as the programmer are asserting that there are no side effects. Tooling doesn't really validate this for you. You could be wrong if you if these side effects are important to your application, then you can get runtime errors, and those can be kind of a pain to debug sometimes. So you should be aware of that when you're using this flag. If you do have specific modules that have side effects that you care about, you can sort of allow list them. Instead of side effects false, you just say side effects, and then you include the files that you care about. That can be useful for migrating that, most of our files don't have side effects, but there's a couple that we still need to deal with. So you allow list the ones that are problems, and then you can slowly fix those over time by changing them to not have those top-level side effects. So with that, I'm done talking about tree shaking. I spent most of this talk discussing that, so we can move on to some of the less tree shaky changes that we've made here outside of the strict flag. These just apply to all projects. So one of the bigger ones is that we've upgraded everybody to TypeScript 3.9. This includes lots of minor improvements here, faster compile, smoother editor experience, stuff like that. From the more developer perspective, specifically promise.all and promise.race now tend to have some more specific types that can be very helpful for you. tsEffects is a new comment that you can use to sort of test that a particular statement would cause a compiler error. Which is really useful for sort of testing things at the compiler level rather than at the runtime level. There's also, if you use a function in a ternary, the compiler will now complain if you forget to call it. So in this scenario, I forgot to put parentheses here, and the compiler would actually throw an error about this, which is really useful. So there's more information there. I'm not going to go into all the details about TypeScript 3.9, but those are some of the major things that have improved. One of the more significant changes has to do with tsconfig. Believe it or not, we do listen to the community, and we've heard that there's a lot of people out there who believe that we don't have enough tsconfig files in our Angular projects. So we've decided to add another one just to make people happy. We've now gone from 4 tsconfig files to 5. Hopefully that makes our tsconfig lovers a little bit happier. You'll notice that there's a new tsconfig.base.json, which wasn't there before. And if you actually look, it's the same content as what was in the original .tsconfig.json. We've just kind of renamed it. So really the new one is the most simply named tsconfig.json. It's actually the new meaningful file. I won't go into the contents because it's kind of technical and not all that important. But the main advantage of this change is that this new tsconfig file is a solution style, sort of solution style. And what that means is that if you've ever used, regular Visual Studio and worked on like C# projects or other Microsoft style things, Microsoft has this concept of a solution that sort of aggregates all of your projects in a particular workspace. And this allows the editor to be a lot smarter about things than it could be in the past. So for instance, we used to have a tsconfig, well, we still do, this hasn't changed. We have a tsconfig.spec.json file, which allows you to use Jasmine types because we want you to be able to use testing, actually calling it, describe, expect, all those kinds of things. But it only really applies to spec.ts files because those are the test files that you're actually going to be running tests. You shouldn't be using Jasmine in production code. And previously, the editor didn't know about this. This name was not known to VS Code. It wouldn't look at this. It didn't care. But now with solution style changes, it's much more aware about this. So if you use a Jasmine type in a spec.ts file, that will still work today as it always has before. But if you use a Jasmine type in a regular component or any other non-test file, this will now be an error in your editor. And it'll actually warn you, be like, no, you can't use Jasmine here. It's for test only. And so it allows the editor to be a lot smarter and understand the layout of your project much better. We've also taken this opportunity to sort of modernize some of the browser support and browser versions that we support. Most notably, we've removed any browsers that don't support ES 2015. ES 2015, if you're not familiar, it's the spec of JavaScript that includes things like class syntax, arrow functions, things like that. We've removed all of the older browsers that don't support that. And that most notably, that means that differential loading is no longer needed by default. Differential loading was the feature where we would build the application twice, once for newer browsers and once for older browsers. And so now that we've sort of removed those older browsers by default, we don't need that second build. So that makes your builds faster. It means you have a simpler deployment and loading mechanism. Should hopefully make debugging a lot simpler. If you really do want to support those browsers, then you can update browsers list RC and opt back into them. The CLI is smart enough to figure out if you actually need differential loading, and we'll enable it if necessary. But definitely, don't do it just to check a box and support all the browsers. Actually look if your users do really use those browsers. Definitely want to, we've removed these things because we don't think many people need them. That's sort of the main motivation. So do, actually consider it before you opt those browsers back in. One of the other more notable changes is that we've officially deprecated IE 9, 10, and mobile. They're still supported right now, just deprecated. We will drop support in V11. So be aware of that. We've talked a lot with the community. Oops, I clicked the button. Sorry. We've talked a lot with the community about this change, and we found that many of our larger customers, they don't see the value in supporting these versions. jQuery even doesn't really support it. Microsoft itself doesn't really support these versions, and it's just not as important as it has been in the past. We've seen users migrating over through to Edge and other other more modern browsers. So after a lot of discussion and deliberation, we've decided to officially deprecate those. IE 11 is still available. It's not enabled by default, but you can opt into it. And we've definitely still, that's not really going to go anywhere. We expect IE 11 will stick around for some time, but at least the older Internet Explorer versions we're going to be dropping support for. The last little change here is that we've changed the way that Angular package format works a little bit. This is kind of the format if you ever publish an Angular specific library. This is kind of the format that'll be laid out on NPM when you publish it. We used to have ESM5 and flattened ESM5 to support these down-level builds. Now the build structure has changed. So that happens at the end of the process, and the libraries themselves don't need to ship this code. So what that means is that there's less code that needs to be included in your published NPM package. And so just for Angular core libraries, that actually saves about 120 megabytes just from that. And if you're using other third-party libraries, you're going to get even more savings. So that should hopefully make your NPM install experience a little bit better and hopefully lighten the weight of the black hole that is Node modules just a little bit. So with that, that's all the major stuff that I had to talk about. There is, if you want to upgrade today, I definitely encourage it. You just do ng update, CLI and core, and that will get you up to the latest version, runs all our fancy migrations and kind of helps mitigate the breaking changes that you might be expecting. If you're making a new project, I definitely encourage you to try out the strict flag. We're looking for feedback on that. We're hoping to sort of graduate some of these changes to be included by default as much as possible. And we're kind of looking for community feedback on that. There are some more longer form guides about this that talk a little bit more thoroughly. This talk is only about the CLI, so there are some other changes within framework and components and other breaking changes that I didn't really dive into, so definitely look up more on that. And I'm on Twitter if you want to follow me there. I'll just do a shameless plug of that. I tweet about things that I think are cool and things that are kind of frustrating and annoying, and I voice unpopular opinions that I can regret years down the line. So join me on this journey of being on Twitter. And that's pretty much everything I have. So I think at this point we can kind of open it up to questions or comments. I'm not sure exactly how you want to handle this.
Thank you, Doc. Really awesome talk. I always wonder, I was wondering how you did to manage to get Angular 10 out of the door so fast, after the Ivy version just came out. We have a few questions here, so I'm going to highlight them and you're going to be able to see them here in the tool.
Sure.
Are you seeing it here in the stream?
Yes.
Awesome.
So to ensure I understand, if I use --strict, I can't use my new project. I can't use HTTP in my new project. So when I was talking about side effects, what that mostly relates to is being at the side effects at the top level. So if you just use a regular function or an observable, and you call that to make a network request inside your component, inside ng on init or something like that, that's all perfectly fine. Nothing's going to change with that. That's all totally reasonable. Where you're going to run into challenges is if you do that at the root level of a file, at the top level of a file. So that would be, if you were to do that, that would have the side effect of, simply importing this file is going to cause this network request. And that can cause a lot of issues that tree shaking can't really handle effectively. So it's only if you're using those kinds of very specific patterns where you're going to run into issues. Definitely, you can still have other side effects as long as they're contained outside of that top level scope of a module. So definitely doing things within ng on init or within just a regular function call, that's all perfectly reasonable, and that's not going to change.
Awesome. We got another question here.
So if I create a new tsconfig in my project, say for Electron, do I need to add it in the tsconfig.base.json? So this mostly has to do with however you kind of want to structure your tsconfigs. We definitely have this sort of kind of default that we want to encourage. Definitely you are free to restructure it as it makes sense. The base, the role of the base is mainly to just provide common settings that apply to all of your builds, whether that's your production and dev build or your tests, things like that. You typically want to target the same language versions and things like that. So I would recommend, what I would what I would generally recommend is that any new tsconfig I would have that extend the base config and sort of inherit all of those common options that I want throughout the entire project, and then modify some things in there that you need for your particular change. That's sort of the structure that we've had so far, and that's the layout that we recommend. That can have some implications on the new regular tsconfig.json file. That's the solution style. You may want to add your new tsconfig to that. It kind of depends on your use case, so I can't really say too much about how you would go about that. But essentially, by adding it there, you can make the editor a bit smarter and understand your project a little bit better. So I recommend looking up the solution style tsconfig changes in TypeScript, which can kind of help guide you on exactly how you'd want to structure your project to support that.
Awesome. By the way, I see here someone asking, is the presentation available somewhere?
Sorry, is what version available?
The presentation.
Oh, the presentation. I have not posted this yet. I was honestly not sure what the best way of doing that is. I think I'll probably post, I'll probably push it on my Twitter account after this and make a post there. So I guess I didn't really think about this ahead of time, but I'll encourage people to follow me on Twitter, which maybe I should have planned that out in advance. Kind of inflating my numbers. You can follow me afterwards if you want.
Is there anyone has any other questions for Doug before we close the session? I gave everyone like a minute or two and see. So when are you guys pushing B11? Like December? Like next month?
I forget the exact schedule, but I think it's every 6 months or so. I think it's intended for this fall, kind of later in the fall. So we're trying to do more frequent and more stable releases, so that be much more regular about these sorts of updates. We want to get them out on reasonable timeframes. Ivy was kind of an exception because that was such a significant and heavily impacting release, is why that one kind of got delayed and took much longer. But definitely, as you said, V10 kind of seems like it came out pretty quickly, and we're trying to adhere a bit more to that sort of cadence. So hopefully you should be seeing much more consistent releases going forward.
Awesome. Is this roadmap going to be somewhere? I know that Jeremy told us in our session before that the roadmap for Angular and the new things coming is going to be like publicly somewhere. Is that coming out?
I believe we're working on that. I'm not sure if that's totally published yet. I know there are some discussions about trying to be a bit more transparent about our roadmap. Definitely the actual version, at least the idea is that as we update each version and we have a more consistent cadence, that will allow us to sort of ship features just as they're ready. And like, if it's not quite ready and it misses V10, then it's not too big a deal. We can just sort of delay it until 10.1 or something like that. So it's a lot of it is more about when a particular feature is ready rather than necessarily trying to align with specific version numbers and sort of fit, kind of decouple the version release from the features that are included in it. So hopefully it should be a little bit more consistent that way. And I think trying to be a little bit more transparent about the roadmap, but as a result, the roadmap itself isn't directly tied to version numbers in the same sense.
Cool. I see someone here. Talk about ESLint versus TSLint. If you want to, you can say a word about it.
Sure. So if you're not aware, TSLint has been, I guess it's basically just officially deprecated, from my understanding. I'm not sure exactly how they're positioning it, but it's more or less deprecated. And currently, we're still supporting TSLint at the moment. We are exploring how we can sort of migrate and gracefully change to more ESLint focused structure. That's not quite in yet. There's a lot of complexity that comes with that. It's not a one-to-one conversion. We want to try and minimize the amount of changes that affect end users or end developers. So we're still evaluating that. We're definitely looking into it. It's one of those things that it sounds really straightforward, but it's a lot more complicated than you might think. So I've got some really great people working on that. I know Minko from DevRel, you've probably seen him around a lot in the community. He's been doing a lot of great work there, and so we're definitely going to move in the direction of ESLint right now is kind of the current plan. It's just really a big question of how we get there and how we can do it in the best way possible without causing a whole lot of breaking changes and causing a whole lot of pain within the developer ecosystem. So we're definitely working on that, and we definitely want to see some changes there.
I hope that answers your question, Lars. I don't see any more questions, so I think we're done for today. So if anyone has more questions for Doc, they can see his Twitter handle here in the presentation. If you have any questions regarding our events here at this dot, feel free to reach us out at this.media or this.labs, and we'll answer any questions you have. We'll tell you about our coming soon events and much more. And well, thank you everyone for watching us, and feel free to join to our future sessions. Bye.
Yeah, thank you so much.